Okay, it's recording. All right, and Susan, again, I'll be able to share. Do I have host, co-host? Okay. And I'm able to share, right? Okay. All right, first day jitters, guys. I wasn't able to log on, but I copied the link that ends at 4499 and I was able to get on. Hopefully all of you can hear me. Good.
I'm going to sign off, Rudy, if that's okay with you.
Just one more. How many people are enrolled? I saw.
You should have, let's see, there should be 8.
Okay, 8 people. That's right. There should be 8. Okay, so we'll wait a couple of minutes for a full house and get this ball rolling. And I can share the screen apparently. Okay. All right, Susan, you can go.
All right, I'm going to send you a snapshot quick of who's should be here. I'll email you.
Oh, also, I noticed in the email that you sent out, the hyperlink doesn't work. You have to.
Yeah, I don't know what happened. There's somehow a different link. It should be definitely the one that ended with 4499. I don't know how that other link with something with the 7 ended up in there.
Yeah, there's like when you click on the one with the 4499, for some reason it includes another like / in the URL.
Yeah, I saw that. So I quick deleted it out of your, and Anna's emailing you. So let me go and see if I can help her out. She's trying to get in.
Thank you.
Thanks, guys. Sorry about the confusion.
Right.
First day things we're trying to get through.
And there's 8 people enrolled, so there's a couple of more people waiting to join. So listen, welcome to the new semester. What happened to the old semester? Just merged into one. So 461. So before actually, just welcome to this class. This is, you guys are pioneers in some ways. This is the first time this will be is being offered for credit. We've been doing this for many years now and decided that this is rich enough, fits into our mission statement. So I'll go over all that in the preview before the speaker, i.e. me, presents to not only you guys, but to a lot, another audience will be in the room, as it were. So there's a lot of balls in the air. And the fact that the link didn't work the first time around, I'm not surprised, but I did panic a little bit. So this is wait a few minutes for everybody else to join. They may be having the same problems, Leanne, that you had, and I apparently had too. All right, so how was your week off? The week you had between the summer semester and the fall semester?
It was pretty short.
Well, that goes.
It was good.
But I hope you made full use of whatever time you had. Let's see, we got 5 people, 3 more to join. Hello, Matt, Sarah. Okay, so we're waiting for 3 more people to join. Okay. Okay, we got 6 people. There's 2 people still. Okay, Ryan has joined. Hey, Ryan. Anna.
Hi.
Okay, one more person. And hey, Ryan.
Hey, what's going on, everybody? That was a pain.
Yeah, okay, Maurice has joined. So all of us have had the same problem. So hopefully we won't have it next time. So Maurice, welcome.
Good morning.
Good morning, everybody. Full house. All of you had some hiccups joining, as did I, but you recovered. That's great. And so again, welcome to ESE 461, energy seminars and field trips. And we had been doing this for the last 3-4 years, and this is the first time we're doing it for credit. So you guys are enrolled for 3 credits for this course. So welcome. You guys are pioneers, and you know what happens to pioneers. You do sometimes have arrows on your back, but you know, I'll work with you guys as we go forward. Okay, so can you see my screen? It has a PowerPoint. Okay. And so let me just walk you through this class today, and most of the classes are going to be of the form that we would experience today. So the enrolled students, all of you, we will meet about an hour before the seminar starts. When that happens, there's a larger audience that comes in, which includes industry personnel and so on. So we had been doing this in the past, so that's no surprise, but the new part is we bring in a larger audience while we're talking to the enrolled students, you guys. So again, let me give you what to expect in this 3-credit course for the next 16 weeks. All right, and so don't be shy. If you have any questions, if you're small enough, where please interrupt me, and I'll try to answer your question. This is being recorded, so let's see, it is being recorded. I don't see any sign that it's being recorded, but I got to take it to word somewhere. Remote control more. Okay, it is being recorded, yes. So let's press on. So you see my next slide. So just want to kind of go over this course, ESE 461. It is offered as remote only because of the very nature of how the curriculum has been put together. It's just much more easy to offer this on a remote only basis. The classroom. And this is the part that I want to make sure you guys don't get confused. The enrolled students, i.e. you guys, 8 of you so far, we'll meet between 10:45 to 12 noon. And typically, we will be doing things that are pertinent, you know, to assignments and your presentations. But today, I'll take this opportunity to lay out what to expect. So between 10:45 and 12 noon, when the seminar starts, we will be just exclusive between you and me, the instructor, you, the students. At 12 noon, that's when the guest speaker enters. And just so you guys know, I am the guest speaker for the first one. I will be laying the groundwork of what topics to expect in the semester. There'll be 8 seminars, really very qualified speakers from around the country, around the world. And that's another reason why this remote only makes it that much more attractive, because we don't have to travel anyplace. We're here sitting and being able to take advantage of people talking about various areas of expertise. And I'll go through some of the details of what topics we'll be going through. This is the part, every guest speaker class, which is there are 8 of them, you'll have unique links. And the reason we have these unique links, as you can well guess, is for security reasons. You know, before, when you had a classroom which was highly circumscribed, you know, the same students came every week for 16 weeks. It's a little different now. In the classroom now, you have different people coming in at different times. So this is one of the burdens we need to bear, that we will have unique links for each of the classes with guest speakers. Now, the classes that don't have guest speakers, they're what I call off weeks. Those I've sent you calendar invitations for. For example, next week is an off week. So it is on a calendar. It isn't yet another different link. So don't want to confuse you, but just want to let you know what the lay of the land is. So look at your calendar invitation and click on that link to access this. And it varies whether you have a guest speaker or whether you don't. I'm going to stop there for a minute and ask you if you have any questions. Clear enough? Okay, and I think that's the last bullet, single link for all off weeks. And when I would say off weeks is when there's no speaker, it will be just you and me. Those are the days then we don't have a guest speaker. So to kind of give you a framework for why energy seminar, I don't know, has any one of you gone through a curriculum that includes seminars, not in energy, but any other subject that you took during undergraduate or graduate studies we went through? Have you been through a seminar curriculum? Anybody?
Yeah, for our senior design project for Lehigh in electrical engineering, we had to attend like 4 or 5 seminars every semester, and yeah, throughout different departments and everything.
Okay, so Matt, you've had that experience. What I want to emphasize, and especially in this hour before the guest speaker comes on, in this case it's me, so I'm talking like I'm Julius Caesar or something like that. What I'll talk about is give you the framework for why we have structured this course the way it is, because of the uniqueness of this program. And you know, when you are looking into joining this program, you may have heard some of this, but if you haven't, let me just go through the framework, why we're doing what we're doing, because I believe these energy seminars are an essential part of our mission statement, which is to produce a new generation of world-class leaders. I think those of you who attended the summer session know that this is not your typical course that you go through. You go through not only written assignments, but speaking assignments too. You're asked to speak in front of your class. That is important. You're asked to look, and part of graduate studies has this component where you do background research on subject matter that you will be studying. That is really important, whether you're doing energy or whether you're studying something else. So this course fits in very aptly, with our mission statement to produce a new generation of world-class leaders. And the learning process, for those of you who are gone through Lehigh, you may have heard of this or seen this. We have an ecosystem in the ESE program that, lays the seeds for success. Just, if you can take a course, and if you're not exposed to what I think are the essential parts to be able to meet our mission statement, I believe that it lacks these qualities, and these qualities are, we have an advisory council. The advisory council is made up of not only Lehigh faculty or past directors of this program, but also industry folks who work with our students as mentors, as project sponsors, as utility personnel. We have utilities represented in the advisory council from Con Ed, from PP&L, and from PSE&G, and these are the local utilities. We did have PICO, but they decided not to come because of the distance. I think they were in Philadelphia, so it was difficult for them to come. But they could participate remotely. But nevertheless, PICO was a part of the advisory council. The other leg of the stool that for this ecosystem is alumni, and that's the 3 o'clock position. And the alumni in Lehigh is pretty well known. Alumni play an intimate role, with all the programs, and it's no surprise in the energy program that is the case. Industry is a third leg of the stool. Again, you guys are being trained for this energy workforce, so it makes great sense, for you to be exposed to industry. And you're exposed to it in 2 ways. One is the advisory council, which is as I said, the first leg of the stool. And the industry is also, you're exposed to the industry through your capstone projects. And we dwelled on that quite a bit, during the 405 class. Most of you who are enrolled in that 405 class have a capstone project you'll be launching under 460. And most of you have either met or been introduced to your industry sponsor. And so industry is a integral part of our ecosystem. And the fourth leg of the stool is the college itself. And some of the electives that you take, are taught by the College of Engineering faculty, or they could be College of Business. There are 4 electives that you need to take to graduate in the Master's of Engineering program. This happens to be one of the electives. This is offered in the fall and the spring, and you can take in both occasions because we have a whole new group of speakers that will be available in the spring, very different from what you'd see in the fall. So this ecosystem that we have, not only for for all of this programs here at Lehigh, specifically so for the energy program, is so essential. And part of this energy seminars is really calling upon industry folks, people with industry experience, talking about energy technology. And what you learn in these energy seminars is not only about the technology, but how does it work in the real world, in the field, as it were. And in the field is not only that are you working in the real world, as I say, but you're working with people. And that can skew or change things, depending upon how the team gets along. These are kind of the softer side of technology implementation. So these energy seminars kind of expose you to real life issues in the implementation of technologies. That's the best way I can put it. So I'll stop for a minute and see if you have any questions. Okay, so hopefully it's shaping your mind as to why the energy seminar is being offered as part of this curriculum. For those of you who are not involved in the energy program curriculum, this would be of interest too. Whatever career you choose to pursue later on, you would have some of the same ingredients for success that you would need in the energy program. I mentioned about the Industry Advisory Council. It's not necessary to know their names, but hopefully, on the days when we had more in-person contact, they would be wandering around during your project symposium, for example, or during classes, or even participating and presenting, during these energy seminars and all of the above. But they play a critical role in the success of this program. So at least it's good to know, that this advisory council exists. Definitely if you know of any one of them or more of them, just let me know and I can introduce you guys, reintroduce you guys. But nevertheless, this is integral part of the learning process in this program. Okay, this is the list of speakers that we have for the semester, starting from today. And my job is not because I got some cool things to say. The only thing I want to talk about today is really, what does the landscape look like? And hopefully all the subsequent talks, fit into the landscape in some form or fashion that will bring you back to what you will have heard today. So that's my motivation for being the first speaker. But let's just walk through on this week of week of Labor Day week. We have it on a Thursday, not obviously on a Monday, because Monday is Labor Day, and we have a speaker from American Water. Now, why would you think there would be somebody who deals with water issues talking about energy? Any guesses?
When you're generating power and other sorts of resources, water's kind of a necessary element, especially with cooling.
Very good answer. In fact, water consumption by utilities with conventional generation is one of the big issues. They're one of the biggest water consumers. So some plants are shooting for net zero water. Okay, because some arid places like Arizona, for example, where plenty of electricity is generated, water is scarce. So we will get a speaker from American Water as an organization talking about water and the other critical infrastructure. Just as energy is a critical infrastructure, water is another critical infrastructure, not only to keep energy going, but for our daily living. It is we need water more than anything else. We've had a lot of water the last few days, but it doesn't last. The third lecture is by Chris Eshelman. He was formerly with Pacific Gas and Electric. He's now a consultant talking about energy risk management. He was with the pricing group at PG&E, and he will be talking about how do utilities manage their risk, either in the procurement of energy or the delivery of energy. It'll be a very interesting talk. The fourth session, and we are now in October, one of my close colleagues, Clint Carter, with Luminant, which is a utility in Texas, talking about fleet-wide monitoring of power industry assets. Again, our topic today that we will be covering at 12 noon, digitization and decentralization, is kind of fits into the theme that will be presented in the fourth seminar. Clint Carter is a director at Luminant. He's taken on a position with the Department of Energy. to lead a consortium of nuclear utility owners that are looking at artificial intelligence and machine learning to be able to manage industry assets. And by the way, Lehigh has a small role to play with this initiative that Clint Carter has initiated with the Department of Energy. And I won't have time to talk about it. Maybe I'll just hint on it in today's seminar. The fifth session on October 11th, one thing that you need to notice that in October, these seminars now are weekly. And by the way, trying to get 8 people every 2 weeks is sometimes a chore. Some people are not available certain times. And just so happened in October, the cadence would be every week we'll be having a guest speaker. Ramesh James, he was a vice president of the Nuclear Energy Institute. And he's now a consultant, and he will be talking about, how to put energy policy and technologies in some ways where they're linked to each other. Yeah, one would think that energy technology kind of takes precedence over policy, but you guys would be surprised, and if you're not surprised, that's great. Policy always wins, and policy is not made up of engineers. And so most of us have an engineering background or a STEM background. We sometimes get frustrated because you think, well, why isn't policy paying more attention to what I think is a cool technology? And Revis has worked in this space for quite some time, and he has some ideas. In fact, he and I have been talking about maybe having an elective in the future, with 3-credit elective that brings together policy and energy in a more rational manner. It's surprising that it's a difficult two subjects to be brought together, and if anybody can do it, Revis could. And so I'm looking forward to that presentation. Any questions so far? We're halfway through all the seminars I'm going to talk about. Each seminar will be roughly 90 minutes, 60 minutes presentations, 30 minutes Q&A, or some combinations thereof. October 18th, we take a little bit of a break from seminars and actually go out on a field trip. Be visiting this net zero building in Shanksville, which is operated by this company called Sustainable Energy Fund. And full disclosure, I'm a board member of that company, and they do some very interesting work. And so this net zero building was commissioned just before the pandemic. So they've been having trouble getting occupancy. The whole idea was to bring in another company. But on this visit, we will look at, what is the carbon footprint of this organization. And I'll leave some surprises for what you'll hear that day. It is really remarkable. If every company can do this, they can be very sustainable as far as energy is concerned. So that's October 18th. We'll do this field trip. It's in Shanksville, so it was a short drive. We'll stay there for a couple of hours to hear from different speakers. The last 3 speakers, one's on looking at managing the grid with increased penetration of DERs. Now, the grid that we have today in the US is maybe 10% of something other than conventional generation. So very heavy with central generation assets like coal plants, natural gas combined cycle plants, and the nuclear plants. Even though renewables is a rising percentage, it is rising from a very small base. So there are countries, where the portfolio that make up the generation is majority distributed energy resources, solar, wind, and so on. Can anybody think of a country that is majority distributed energy generation, DERs? Or even 90% DERs?
Sorry, isn't
Go ahead,
Denmark, isn't Denmark pretty
Very
big
good,
in
Ryan.
DERs?
And yes, they're almost 100%. Very Ørsted, which is putting out wind, offshore wind farms in New Jersey, New York, is being managed by Ørsted. Anybody, any other country you can think of? Costa Rica? Anybody heard of that country? Costa Rica is almost 100% renewables. Any other guesses? Iceland? And I believe Norway is there too in that group. Now, I know the Biden administration is going heavily into, well, I know definitely electric vehicles, but they do want to meet Paris Accords, and that's another story in itself. So there is a promise that renewables will be a much bigger fraction of the power energy portfolio than it is today. But the one issue is, how do you manage the grid? You know, we depend upon synchronous motors for managing the grid, you know, the way we are set up. As we transition to more and more penetration of DERs, you'll hear a talk from EPRI. Deepak will be talking about how can it be done. Very interesting talk, is very forward-looking. Here's one on seminar 7. It is truly out of this world. Ubiquitous solar power. What do you think I mean by this? Ubiquitous solar power. Solar energy 24/7. And solar energy 24/7 means you need the receptors in outer space, because that's where sunlight is there constantly. And believe it or not, Caltech is doing some very interesting work in solar, outer space solar, and we'll have Dr. Vaidya, or possibly a substitute for her, because she's medically not, she won't be able to make this presentation. I'm waiting to hear from her who's going to take her place. By the way, that's the reason why this is not green. It's not being confirmed yet who the speaker is. And the last in the series would be the future of nuclear, from EPRI, Tina Taylor. She's wearing a couple of hats. She's not only a guest speaker, but she's also one of the project managers for a capstone project that we are conducting this year. All right, so let's press on. This is how we advertise these talks. I don't know if you saw this advertisement for my talk, but this is put out well in advance so that it draws an audience. In this case, we had Neva Espinosa from EPRI. She's a vice president now, talking about deep decarbonization last year, September 2020, this last year, right? We also do field trips as part of this learning process. Here we are at Con Ed, and last 2020, spring of 2020, we were at PP&L Control Center. Your field trip this fall would be, of course, at the Net Zero building. And in the spring, there'll be one that Scott Thomas, who will be teaching 402, will take you guys on another field trip. So what will we do in this class? So there's 8 seminars to 1 field trip. You've got the blow-by-blow account. All seminars are virtual. There will be assignments for every talk that you hear. There'll be written reports expected, and I'll go through the logistics, how big and so on. But I'm also doing something new that I haven't tried before, is to have 2 special audio assignments. And guys, if you want to make some suggestions on how we do the special audio assignments after I go through this, please feel free. And I'm still not thinking about how we discuss these audio assignments, the assignments in general, even though you'd think that off week, there'd be 8 off weeks because of the math and the holidays, Thanksgiving will be one, and the Labor Day being another. The off weeks are not as many as you think there are. There are, I think, 4 or 5, not 8 as I thought they may be. But the off weeks, we'd be discussing the assignments. And this is the special audio assignment that I want to have you guys consider. Now, the math of the number of enrollees, enrollment, and this number of speakers is magically 8 and 8. Isn't that great? But if it were to change, we'll adjust. But there are 8 enrollees and there are 8 topics, guys. And the first thing I want you guys to do, and not right now, but offline, is to form 4 two-person teams. And let's call them teams A, B, C, and D. Okay, so is that bullet pretty clear? You know, after we finish this class, talk among yourselves, figure out how you want to form your team. If you're having trouble, send me a note, but I'm assuming that you'll be able to do this without my intervention. So is the first bullet clear? Okay. Now, once you form this team, each team pick 2 seminar topics from the 8 to be presented. And each team pick must be unique. One from the first 4 and another from the second bottom 4, 5 through 8. So team A should take 1 from one of these topics, 1 through 4, and 1 from these topics, 5 through 8. And I get kind of given some examples here. Like team A could pick topics 2 and 5, team B could take topics 3 and 8. That's just an example. But the whole thing is, I want each of these teams to pick 2 unique topics from the mix. And there's a method for my madness. So what would be involved is a lot of talking among yourselves. But is this step clear or unclear? What you do in the audio assignment, I'll get to in the last slide. Okay, so once you form these teams and once you pick these topics and this 8 and 8 is working to our advantage, each of you will have 2 topics that are unique. Each of the teams will have 2 topics that are unique. And so this is what I want you to do: form a 2-person team, pick 2 topics, share this with the class, and then resolve it among yourselves. You know, there's duplication, talk it out among yourself. Involve me only if I need to be involved. But I would need by the end of this week what the team members are and what topics you want to pick. So what do I want you to do? Put together an audio commentary of each of these topics. You know, I call it a podcast, or it could be a straight recording. You can have music and fanfare. I mean, that's your choice. I'm not necessarily going to give you credit, but creativity is also part of a podcast. I've asked you to kind of nominally have a podcast that's 15 minutes long for each of those topics. You guys as a team, you could do this together. You could be, like two co-anchors, on a TV show or a radio show, I should say. Or one could take one topic, the other could take the other topic, but any combination thereof. But I want the team to work together on this. So along with the written report, these audio assignments, and as you can guess, there are 8 audio assignments. We will have a chance to listen to them throughout the semester, and how we do that and when we'll decide as we go along. I won't surprise you saying you're up, you'll have advance notice to be able to present this, but you'll have a lot of time to put it together too, hopefully. Have I confused you enough? Does it look doable to you guys? Okay. And I like, as I said, I like as much as possible for you guys to resolve this, talk among yourselves, which is, again, another part of this program is collaboration, working together. I do expect that you guys will come up with a solution. So again, to repeat, form a 2-person team and form a 2-person team and pick one of 2 seminar topics, one from the top 4, another from the bottom 4. By the way, the top and bottom I'm referring to chronological, it has nothing to do with the topic themselves. And they share this with the class so that everybody knows what you picked and they're all unique and you're good to go. All right, any questions? Any questions on the audio assignment? What do I mean by that? Have you done this in any other curriculum before, an audio assignment? If it's new, well, we'll kind of struggle together. But I think this is my last slide, yes. So this is before we start the presentation. In this case, today it's me, so I'll be doing a lot of talking. I also want to remind you that this audience is going to grow quite a bit. Any questions on what we covered, what we'll do in this course? And if you go, and I do have course site, please go there. And the syllabus is spelled out there. The seminar talk, the seminar lineup is also on course site. And by the way, if things have to be shuffled around as the semester goes along, it might happen. Some people may not be available for whatever reason. That's the risk we take sometimes. Any questions on what your actions are for this course, at least by tomorrow, one, and by the end of this week for another? By the end of this week, I just want to know which team will be taking on this audio assignment for what topics. And if you guys, during the course of this the semester, things have to change, you want to shuffle around, that can happen too. We can be flexible. Any questions, guys? All right.
I can
okay.
I can send out an
I'm sorry, who's that? I'm gonna stop sharing. Okay, go ahead. Can't hear you. Can you hear Liam? Anybody? No, Liam, you're on mute.
Can you hear me now?
Now we can hear you. Good.
I can send out an Excel sheet so we can just keep this organized.
Thank you, Liam. You be a scorekeeper. Liam has volunteered. Thank you. That'll ease my confusion, your confusion, everybody's confusion. Thank you. Any questions on the audio assignment? Again, I want to ask this question again. Have you guys done an audio assignment before? Okay.
I had to do audio assignments for one of my English classes. They're actually really fun to do, though.
Oh, they are fun. In fact, in real life, when you take on a career in energy, you may have to do it very frequently.
Mhm.
So there's a good practice. But Anna, what was your experience when you went through this in the English class?
So we had to do, because it was COVID, we had to do virtual tours of museums and do an audio assignment explaining exactly what we saw on them. I don't know, it was about like 20 minutes long, but they were really fun to like describe the place that we went to. I think we ended up doing a national park, and it was all about like the nature and like, what do you feel, what were the feelings? It was pretty fun.
Good. Well, that's good. Thank you, Anna, for that very optimistic view. It's going to be fun, guys. You have a chance to express yourself. And by the way, there's no right answer. No, I mean, if you take a stance, it's a stance. You know, I mean, I'm not going to say, well, you're not right there. It's your stance. It's a commentary that I'm looking for. And as a team, you know, you could be creative. You could have each of you talking about pros and cons. Think about it. All right. All right. So today I was kind of laying the groundwork for what to expect in this course. Future classes, we will be visiting some of the written reports and the audio reports. As I said, there'll be, at the end of the day, we'll have 8 audio reports, and I want to sprinkle them throughout the semester so that we can space it out as much as possible. All right. If there are no other questions, you can stay online. We will start the other event at 12 noon. Any questions for me? How many of you attended this energy seminar before? This one offered by ESE. Margaret, you've attended this, right?
I think I attended one on offshore wind. It was a few years ago.
Yes.
Yeah.
How about you, Ryan? Did you say you've attended?
I think I was in one last spring. We were talking about the early detection system.
Okay.
That was when I was still deciding if I was going to get into the program or not. I think.
Okay. All right, so some of you have attended these and you know the lay of the land. Basically, the guest speaker, as I mentioned before, has a stage for roughly 90 minutes. It lasts from 12 to 1:30. he or she can choose to split that up any which way. I've seen people talk much less and take questions much more. I've had panel discussions before. We're not doing any panels this time around. Panel discussions are very interesting too. Normally I have the students ask the questions first. They get first dibs, as it were. And so, please, you and there'll be other students who are not enrolled in this program who join, I think. Be open with the questions you have. I think each of the topics is quite interesting in itself. So go ahead and ask questions. And then there'll be a lot of industry folks. Obviously, they're bringing in expertise from having been exposed perhaps to that technology. But sometimes they grandstand too, so nevertheless, it'll be a fun interaction. Hopefully this would be something that you would remember as you go forward. So if you want, you can take a break now. We will reconvene about 5 or 10 minutes before noon hour. If you want, you can take a break and come back in 5 or 10 minutes. I see that some of the outside guests have already joined in. Okay. Take a 5-10 minute break. We'll get back.
Is there somewhere that I can find the list of all the topics?
Oh, it's on course site. You mean the seminars?
Yes.
It's on course site. Yes, it's on course site. Are you able to get
Okay,
on
thank
course
you.
site? Yeah.
No.
Liam, if you want, I'll send you an email with that, just so you have it since you've taken on
Thank you.
this.
Yeah, I'm not in any course sites right now, so I think I have to email Susan. But thank you.
Okay.
Yeah, I also don't have access to the course site. It's still from the summer semester class.
Yeah. I think Liam, because he's going to, well, okay, I think everybody needs. I'll send it to you guys. I'll send it to Liam first. And Liam, if you don't mind sending it to every others, can you do that?
Yeah. Mhm.
And as I said, I'm wearing two hats today. One is being the MC for this program, as well as being the speaker. Now, I don't want to speak because I want to speak. It's because I want to lay the groundwork for what the subsequent topics would be based on. And the title of my presentation today is The Electric Utility Landscape and Digitization, Decentralization, Decarbonization. And I'm sorry, I'm an academic, we like these long words and a mouthful. I wish there was something more slick that I could encapsulate these 3 Ds as they're called. But I just also want to let you know that what I'll be covering today, hopefully some of the topics that you'll hear in the rest of the semester will be a deeper dive in some of these areas. Okay, my thing is frozen here, so here we go. All right, so you can see the slide has changed. So what am I going to talk about? So before I get into this was based on a paper I published in Energy Central this past spring, I believe it was, on the trends in generation. And so a lot of that material, and I do have a reference list at the very end. If you wanted to get a copy of the paper that was written, which this talk is based on, you could access that on Energy Central. For those of you who have not been on Energy Central, it's a free website. I really strongly recommend that you take membership. There's no obligation, and they have some very good articles that are published almost on a daily basis. So the main bullets I'll be covering today, again, the format of these such presentations is I would take roughly an hour or maybe less to cover what I need to speak on. And then I'll open the floor for Q&A. And just as before, I'd like to have the students at Lehigh have first dibs on questions, and then we'll migrate over to the rest of the audience. There's 2 ways you can ask questions. There's a chat box. If you choose to enter your question there, that's fine. Or unmute yourself and ask the question, and I will get to it. All right, so what I'm going to cover are what are the 3 Ds, those 3 mouthful words: digitization, decentralization, and decarbonization. What are the drivers and what's the evidence we see of them? In other words, are utilities really digitizing more than they ever were? The short answer is yes. Are they decentralizing? The short answer is yes. And decarbonizing, short answer is yes. So hopefully we'll hear a lot more details, not only in today's class, but in subsequent topics. And I want to close off with what our role is at the Energy Systems Engineering program. We are fit into this, hopefully in very creative and educative ways. And we'll talk a little bit about that towards the end. And then, of course, question and answers at the very end. So electricity has been a prime mover for the economy. This is a graph that you see here, which is, by the way, the time scale is on the bottom axis, starts from 1929. For those of you who remember, 1929 was start of the Great Depression, all the way up to present day. And on the vertical axis, you have GDP per capita in dollars. So 50,000 is the maximum here, and on the scale here. So it maps the GDP over the years, over the millennium, as it were. And 2 things stand out very strongly: strong GDP growth for both Western Europe and the US in the last century, especially from 1940s, World War II onwards to the end of the century. And then now you have the similar climb exhibited by China and India. And in fact, the GDP per capita has kind of levels off here, but don't be fooled. It is being plotted on a log scale, I believe. Yes, log scale. So, so it's not rising as fast as it were. The one common denominator that I can point to very strongly is during this phase, Western Europe growth and US growth, there was rising consumption of electricity that coupled rising GDP. So the link was absolutely certain. That is because of electrification where GDP grew. Now, China and India is coming late to the party, as it were. They were somewhat flat in the last century, but you can see that what you're seeing is a rise in GDP, especially of China and of India, is because they are building electric power plants. They're believing electrification as being the key to expanding the economy. So I think this graph very nicely shows what happened in the Western world and what is happening now in Asia. In fact, we think about decarbonization. These two countries are the two of the three biggest polluters now. And as we decarbonize, we'll have a tough story, a tough sledging here, because to convince these countries that, hey, you need to cut back on fossil fuel electricity, there's something that they're not going to take very lightly because they're progressing in their economy. So it's kind of a preview of some of the issues that could crop up when we tackle climate change, which is going to be the seminal problem that all countries will be dealing with henceforth. So this pie chart shows the fuel mix of for electricity generation, and this is in energy produced by each of these fuels: air, nuclear, natural gas, coal, other, and hydro. Other, by the way, is includes renewables. So you can see the dominance of fossil-based fuels, even today, as recently as 2019. If you do the math, is roughly 60% of all electricity generation. The remaining 40% is made up of nuclear and hydroelectric, and a small percentage by renewables and others. There's no doubt that this green pie slice of the pie is the fastest growing, but is growing from a very small base. We're still kind of having to work with natural gas and coal as our primary ways of being able to generate electricity. And the good news is we have ample access to these resources. We have a lot of coal. Pennsylvania is coal rich, as is Wyoming and other states. Natural gas, the shale gas has caused a revolution. In fact, once upon a time, coal was the king, coal was king, and everybody else was below coal. Now, right now, you can see coal is running a distant second. It may kind of, as we look forward, it probably would be less than nuclear in the next decade or so. The other thing that I want to point out is nuclear. We have very good operational experience. We've had nuclear plants working for the last 7 decades. And other than France, there's no other fleet as big as the US fleet. The US fleet is the largest in terms of nameplate capacity, the energy generated. But France has a bigger proportion of their nuclear energy compared to the other resources. So it's good to kind of keep this in mind, especially as we look at the subject of decarbonization. We have a big thing to climb, a big hill to climb, to be able to get away from these carbon-based fuels to cleaner fuels. And why do we need to get away from carbon fuels? And this graph, which is very commonly available these days, looks at the warming projections if we were to continue business as usual. I cannot see the numbers, but I remember it'll be 4 degrees centigrade above a baseline, which is the temperature as it was in 1990, I believe. So if we were to go on the current path, the temperature rise is going to be less dramatic than 4 degrees, but yet troublesome enough as far as the effects on weather and climate. Where we stand, even with pledges, is not strong enough to be able to get over the challenges of climate change. Long story short, fellas, is that we need to be operating with emissions in this range and below. And that is the challenge of decarbonization. So if I were to summarize what's driving digitization, what's driving decentralization, it is simply put decarbonization. It's not all of it. Digitization has its own uses, especially with asset information being available through cloud services. Now you can access information anywhere, anytime. But no doubt it is one of the drivers is decarbonization, and we kind of go through this in the rest of the lecture. So for those of you in the business, this is not a surprise. The traditional grid has given way to a modern grid. And what was a traditional grid was very linear. You had the generators off away from site and far away, and you had consumers on the other end, and the twain only met through wires that didn't really meet physically. Now, the modern grid, it is much more intimate, as it were. You have solar rooftops, you have electric vehicles being charged, and so you have two-way flow of electrons. The grid was never designed to handle two-way flow of electrons, and that has brought in a whole new challenge as to how you accommodate the decentralized assets, electric vehicles, electric storage at commercial facilities, and solar roofs. The solar roofs proliferate in Pennsylvania, especially in warehouses. And so this grid that was there in the 20th century is giving way to today, as we speak, to something that looks like this. That's caused by decentralization, of course, and digitization is part of that story. So what is the pace of change? That's what's it could be different. Some countries are advancing this digitization and decentralization more rapidly than we are, perhaps. But there's no doubt, since we are such large consumers of electricity, even today, I think China has just overtaken US as far as total consumption, but per capita consumption of electricity is the highest in the US. The pace of change in moving over to this 3Ds, as it were, is very much dependent upon geolocation, very much dependent upon policies in these places. It's also being driven by the customers. In an internet world, the customer is front and center. Yeah, we're seeing this in every other industry, and so no surprise in the energy industry too. This is becoming very strong. And social equity, something is being exposed today, is where is this environmental justice? That's a new phrase that has been used. Is there justice being served as we decarbonize, as we digitize, as we decentralize? Is there social equity? So these are things that govern the pace of change. again, just to recap, what is digitization? You store energy asset operational and maintenance data for diagnostics and prognostics, and just for history. Cloud services, having worked at a utility for many years and worked with utilities before, it was heresy to think that a utility will allow anybody to access their data. But now with cloud services and the need for technology, especially artificial intelligence and machine learning, cloud services are playing a bigger and a bigger role, and digitization is part of that. Decentralization, I don't have to tell you the story of the rise of solar and wind. In a matter of a couple of decades, the prices have come down. What is called the levelized cost of electricity has come down a couple of orders of magnitude. When you talked about maybe tens of dollars per watt for solar and for wind, now you can talk, frankly, in the less than $1 per watt level of, kilowatt hour generation from solar and wind. So that's a very good trend. That's because of the bigger use of this technology, materials that go towards making this technology. You hear about wind turbines, which are, football field long. I mean, you can't even imagine these wind turbines spinning the length of a football field. But that's all added to the capacity of wind generation and brought down the cost, obviously. And decarbonization, again, this is driven solely because of the climate change. Wanting to have less carbon-based fuels, or if you're using carbon-based fuels, to have efficient ways of capturing the carbon before it's released into the air. And the reasons for that I showed in the graph before. It's because of the deleterious effect of climate that could be manifest much more strongly in the next 2 or 3 decades. Again, I may be repeating myself. Digitization allows you to do all this, but just my own personal experience in this world performing diagnostics and prognostics, digitization has come such a long way. Before you would have to have turbine experts, based at every large fossil plant or a nuclear plant. And now, with this capability of digitization, you can basically have diffused expertise. A turbine expert, maybe at Comanche Peak, physically could be diagnosing problems at a plant owned by an Xcel Energy utility. So that kind of possibility is real. And I had some very interesting experience in this area, which made me a big believer of where digitization can go in reducing operation and maintenance costs. And now we have the promise of machine learning and AI that could be, you could enter into, which creates capabilities that were frankly unheard of before. So that's the promise of digitization, and the ability to use cloud, adds to this. Another thing is the second bullet, ability to collate and aggregate information to provide various services, demand response. The whole idea of virtual power plant, I'll talk a little bit about that, is really come about because of this particular capability in bullet 2. I just wanted to show you this, a reactor coolant pump. This actually, even this slide is somewhat dated. We used to call it signature analysis. The way this very important component system in a nuclear power plant, one of the failure modes, specific signatures that are indicative, that could prognosticate an upcoming failure mode. These are now can be fed into empirical algorithms, machine learning algorithms that are able to predict or infer a operational issue with a important component like a reactor coolant pump, to be able to warn the operators that you need to take care of it before you run anything further. So this capability is it was remarkable that you could actually do this through digitization, and we used to call it pattern recognition, but now adapt artificial intelligence and machine learning are the buzzwords these days. Another thing that has kind of become mature is this. You see this picture of the Power Optimization Center. I borrowed this picture from the Luminant Power Organization. They're able to look at their entire fleet of nuclear, natural gas, and coal plants. Again, I'm sorry, I need to correct myself. This was a different utility before. Luminant had only rights to, I think they were able to operate some of their fossil fuel plants and the nuclear, but not all. But they handle the wire, and they don't handle the wires, I believe. But this Advanced Monitoring and Diagnostic Center has become a template for other utilities to adopt this. And this can only come about because you're able to digitize information at each of these asset areas and have a centralized capability, expertise to be able to disposition, what the operator is seeing. Was a big step from what used to be done to what was done a decade or so ago, and what can be done as we go even into the future. The second D, decentralization. Again, not to repeat myself, but it's because of distributed energy resources at consumer sites. Net metering is a phrase that we're all very familiar with. And for those of you in the know, net metering policies in the US is 50 states have 50 policies almost. They're not all the same. But just the fact that you're able to generate electricity at consumer sites and put it on the grid or utilize it for yourself, is a whole new way of looking at this business, and decentralization is the reason. The second bullet shows a interesting thing that is cropping up. Looking at DERMS, distributed energy resource management systems at the distribution level. There are some not only technical issues, but very strong political pushes and pulls here. A grid operator would want to have complete control of everything that he or she is managing, from the grid. But you can see there are some vendors there that think it can be done with a distributed management system, but this is coming to the fore quite strongly. And the whole idea of decentralized capability is kind of being manifest. Again, this is shows the growth of solar. Those different colors indicate, are they utility solar, are they residential solar? They do have a little difference as far as price is concerned, as per kilowatt hour. But you can see the majority of the growth, the big part of the growth is in utility solar, because no doubt about because of the cost. There's a very thin green line that refers to concentrated solar. It's not very popular, but it has its place. I mentioned about virtual power plant. This is becoming pretty popular, especially to meet peak demands where grid operators need to purchase very expensive wholesale power. And sometimes they go broke, because it is so expensive that they cannot pass it on to the retail customers. Or if they do, they rent the spleen like Texas did. But this idea of this virtual power plant is where customer assets themselves could be marshaled to create what the phrase suggests, a virtual power plant. And, this seems something out of science fiction, but really for urban utilities, this is a big plus, because of their ability to put together, say, commercial solar rooftops and storage capabilities to be able to meet peak demand means, they could stitch together a power plant through the power of the internet and through the power of aggregation, and avoid buying very expensive power for those peak demand times. And those, by the way, I know Con Ed has a statistic that before they were able to use things like demand response and things like virtual power plants, their peak demand was almost 50% of the overall budget. And for just meeting that for maybe 1 week in a year kind of equivalent. They could get away with using modern technology, which relies on digitized and decentralized assets, virtual power plant being one of them. Now, decarbonization is kind of the thing that's driving all this. I don't want to go through the detailed statistics. The Ipcc guidelines are pretty stringent. And I don't know if any of you caught the latest report. I think it was the 6th report, and it is graver than before, obviously, but saying that climate change is going to affect every region, every part of this world. And so this mandate to decrease it to no more than 1.5 to 2 degrees centigrade above baseline is unfortunately something that needs to be adhered to. Otherwise, the consequences, as we've witnessed these past few years, and probably will be witnessing in future years, the consequences could be drastic. So electrification is a solution, but it's not only in the supply of fuels. I remember my first graph I showed that more than 60% of our fuel source for electricity is carbon-based. So it'll be very difficult to wean away from that without some price being paid in the journey, not to talk about divisions, division of thought, political divisions, all this could play a role. But not only do we need to look at the electricity generation that needs to be carbon-free, but also make other carbon-intensive industries like concrete, like cement making, like transportation. They need to be free of carbon too. I know that the administration is looking at 2035 to have a fully electric fleet of cars. I think it's 2035. I know 2030, they were aiming for 50%, but I know some of the auto manufacturers themselves taken upon themselves to have an all electric fleet in a decade or less. And why transportation? Because the total greenhouse gas emissions is a big chunk of transportation, it's 28%. So, on paper, if you were to electrify this entire chunk, which is not an easy thing to do, that accounts almost, if you were to do the same thing with electricity. Electricity, transportation, and industry, give or take a couple of points, are kind of equal burden of the greenhouse gas emissions. So not only do we need to decarbonize the supply of electricity, but also in the demand side of the industry and transportation and in other industrial pursuits. I borrowed this graph from Ernst & Young when they made a presentation about the electrification of vehicles. I know the Biden administration has a very ambitious plan, but both China and India have equally ambitious plans. I mean, they don't have the vehicular traffic that US has, but definitely they are growing rapidly. And they're looking at an electrified fleet as much as the US, the Biden administration is looking at too. So you can see electric vehicles are probably going to get there faster than we expected, unless something trips them up. There could be some safety issues, we don't know. But nevertheless, China and India are definitely, they're coming from a very low base for motor vehicles, but they're expanding very rapidly, and that too with electric vehicles and not internal combustion engine vehicles. Here's the sad part of the story is if you look at the pathway for decarbonization, the utilities, and these are 4 major utilities. I'm showing here Southern Company, Duke Energy, Dominion, Next Era. Where's Excel? I thought I had Excel somewhere here. Well, that's this yellow line. That's Excel here. Other than Excel, you can see, other than Excel and Next Era, their integrated resource plan for these 3 major utilities, Southern and Duke. Duke is the largest utility in the US. They seem to be falling short of the Ipcc goals. This is the pathway for reducing not having temperatures above 1.5, 2 degrees centigrade. These paths are obviously in conflict with this particular pathway, and Next Era and Xcel Energy, to their credit, they are following this pathway, but they're not big utilities. These are the big boys right here. So not very promising news as far as in resource planning for these utilities. So the report card, based on what we're seeing is we're falling short of interim goals. Technology for carbon capture, which was a technology that was highly touted. They had demonstration at Plant Kerner, operated by Southern Company. Unfortunately, that was not very successful. And, definitely, the 3 largest polluters, as I mentioned, they have their differences. You can believe that both China and India are going to say, well, wait a minute, let's have our turn polluting so that you guys have done your pollution. It gets you nowhere. The fact remains that greenhouse gases the inventory is growing, and we need to reduce that. And the one thing that the US has done is kind of taking the leadership role. So hopefully there could be some positive trends in the coming years, but we don't know. And so, this is something that I have put a paper on this, that we ought to be looking at nuclear energy more strongly as a partner to renewable energy, because we have a very good track record in the US. We've had accidents, don't get me wrong. We have this problem of nuclear waste, that is an issue. But if you look at the overall nuclear waste, it is pretty well managed, that's the best way I could put it. There are some very new and interesting technologies that are on the horizon. One of them is going through a demonstration process, the Tearaway, which has the capability of utilizing spent fuel rods as fuel to generate nuclear electricity. And so theoretically, you could bring that radiation level down of nuclear waste to 0. That's a very promising thing to look forward to that works out. So I think nuclear energy should be given more interest as far as a clean energy system is concerned. This graph shows that it's kind of a complicated graph, but all I want you to focus on is the capacity of nuclear is this slice of the pie, 9%, but the slice of energy is 20%. All that is saying is that it's able to generate more energy than the other guys put the, natural gas and so on. So it's a very steady performer. It is carbon free. It is something that we have great experience in operations. And if you look back at history, the worst accident we've had was at 3 Mile Island. And in the scheme of things, it was pretty well managed. I don't want to minimize the effect of accidents and so on, because a nuclear accident has this curious effect. A nuclear accident anywhere in the world changes things everywhere in the world. Because of Fukushima, which took place a decade ago, you have Fukushima mandates, by the way, which was caused by a severe earthquake, caused a tsunami, which was, 1 in a 500-year event. And even though the plant was designed to design bases, the design bases fell short. And so the instrumentation for managing the spent fuel pool were disabled, which caused the release of radioactivity. It was a nightmare scenario in many ways. But the nuclear industry is very cautious about this, and we've had very good regulation in the US through the NRC. We have Fukushima mandates, even though, we're not threatened by Fukushima-like events, but you could have a dam burst or a river overflow or climate change causing flooding, like happened in Tennessee yesterday, for the matter. So you have these Fukushima mandates that are safety regulations that nuclear plants in the US need to adhere to. What I'm getting at is that nuclear is carbon-free. It is a good part of our generation mix. We have terrific operational experience. We ought to not only invest in what we have, but invest in future research. Nuclear fusion, if we ever get to there, that could be the answer, but we're far away from addressing practical ways of doing that. So again, I think nuclear should play a larger role in the clean energy system because of our experience. And this graph also shows that the life cycle carbon emissions from different technologies, you can see coal is the overall bad kid on the block, but all the way to the right, nuclear has got a very low carbon footprint if you were to measure this over its life cycle. So all good news. We ought to be able to take advantage of what we have as nuclear assets. So even though, I'm a big fan of all of the above strategies, I don't believe we need to hang our hat on one technology, but I do believe that nuclear energy needs to be given more attention. There are SMRs. For those of you who haven't heard of SMRs, they're more standard kind of a way of building fission-like plants, smaller versions. When I say small, it's all a relative term. So instead of 1,000 megawatt fission reactor, you could have a 6-pack of 25 megawatts each. And that's to answer the question of flexible generation. Especially if climate change solutions need to decarbonize other industries. Now you can think of fuel for cement manufacturing being replaced with SMRs, which could not only supply the electricity, but could also supply the hydrogen, which could be a fuel to be able to service, to fuel that industry. Nuclear waste, again, is a problem, but we need to spend more time and money on research in looking at how nuclear waste could be handled. I don't want to bore you with this graph, but some of the SMRs have some promising numbers. In other words, to reach parity with what is fairly inexpensive combined cycle gas turbines. In different scenarios with a carbon parity price of $10 a $10 a ton of CO2 to $30 a ton of CO2 under private funding, becomes feasible. At $10 a metric ton, if you recall, a decade ago, that was the kind of the price that Congress was debating as reasonable. So what I'm getting at is, if there were a price that were levied on carbon, nuclear becomes a very strong player, even with some of the most inexpensive ways of generating energy through combined cycle gas turbines. This graph, again, for those of you who don't know, we have a lot of nuclear plants, all operating quite well. They've gotten their 40-year license renewed after 4 years. And some of them are going to go for their 6th-year license renewal, because we're finding that they can still be run safely and reliably over the period. I think we had 101 reactors, I believe. I think we're down to 98 or 97, I forget. So overall, pretty good track record and pretty good operational record too. I want to end with what we're doing. So first of all, I painted a grim picture of what the future looks like, how the grid has changed, how the industry has changed. So the bottom line is, I think we need to bring in new minds, young minds, more students, more into the energy field. And that's part of our motto here at ESE, is produce a new generation of world-class leaders. Leadership is important, and that's why the graduates of our program, like many other programs in the US and other places, they need to be able to communicate, to different levels, talk the talk, with nerds like themselves or ourselves, as well as to common people. Energy is a critical infrastructure. You cannot get away without being able to communicate this carefully. We depend on the learning process. We depend upon this learning process that is emulated very well here at sorry guys, which is emulated pretty well. We kind of follow that template in our curriculum. We bring in people with field experience as much as textbook knowledge. We have an advisory council made up of industry folks, and we interact with industry. We have capstone projects which touch upon some of these areas of digitization and decentralization and decarbonization. This is kind of our list of projects that we're doing this year, fiscal year 2022, which promises to be very interesting because we have the largest enrollment in nearly a decade and interesting mix of projects. So in short, I want to kind of emphasize that we need to bring in young minds, and we hope we are setting an example where this could other higher learning institutions can follow, because that's what we need to be able to manage the climate change issues. Got these additional resources if you want to do more reading, but this is the end of my presentation. And so we got a lot of time for Q&A, and so fire away, guys. Susan, I don't know if you're still there. I don't know if you have any in the chat. But if anybody wants to ask a question, please unmute yourself. And
So far, there's just a few comments, but I'll keep looking for. Well, actually, there's one from Jim Daly saying the U.S. Navy has fleets of small nuclear generator plants floating over the oceans in service for years. Why can't we capitalize on their history and experience?
why can't we? Well put, Jim. I think that's exactly what's happening with these small modular reactors. By the way, if you were to just visit Wikipedia and look at SMRs. There are so many people in the game now. And thank God there are a lot of US companies too. Jim has hit that point very strongly. We've had a lot of experience looking at small reactors and yeah, good experience. Yes.
I have a question. You didn't address much about carbon capture or energy storage, which may play also a large role in this. Do they enter in your program at all at Lehigh?
Oh, of course. Let me take the second one first. Storage is necessary for all purposes, whether you're using fossil fuel generation or renewables, because you want to meet demand when the demand is there. Sometimes solar and wind, and they could be out of cycle. Demand may be high, sun doesn't shine. So storage plays a very important role. Now, carbon capture, especially with our fossil fuel plants, that could be a big boon. But I'm afraid the demonstrations that have been conducted so far have not worked out well. If carbon capture or fossil fuel plants were to be put in practice, for that plant to be competitive, the price of carbon, at least I'm thinking some ballpark numbers, it'll have to be about $30 to $40 a ton, for it to have a competitive levelized cost of electricity to solar, for that matter. So it's not that we don't look at it; it's just that.
But isn't that the great reason to have research? I mean, that's what universities to do, right? Long-term research.
So you're absolutely right. In fact, there's a plant that's being run on hydrogen and gas, I believe, in Texas. It's not using fossil; it's replacing fossil fuel with hydrogen and maybe natural gas, which is maybe there's something there. If I said that, I apologize. I think research should be done on all fronts. I'm a strong believer in all of the above strategy. Whether we're doing a lot of research in that area is another question.
And then just to follow on, what role do you think that the United States R&D funding, say public funding, R&D funding, would help with reaching these goals? I don't think we're adequately funded myself in terms of looking seriously at all these issues. What's your view on that?
I'd like to hear somebody else talk about it, but my views, I think we are traditionally, like many other countries, very short-sighted. We want to see results soon. And if a return on investment is several years down the road, there's some CEO there who he or she has her neck on the line, and can people wait for 10, 15 years for results to be proven? I don't know. I think maybe it's human nature, but I don't know why. Long-term R&D is just not favored. Climate change is an area where long-term R&D needs to be looked at. Fusion reaction. I mean, I think that's a very interesting area to spend R&D money on. Because if we were successful there, I mean, that could be the door number 3 that has absolutely solved all the answers about decarbonization and everything else. But anyway, I'm digressing a little bit. Your question was about long-term R&D. Those are my thoughts. I'm sure others may have some thoughts. If you have some thoughts, please articulate them. Any other questions?
Okay, Joe has a question. He says, evidently China uses a lot of high carbon, poor quality coal to produce PV cells. So is that counted in the quote unquote net CO2 benefit of PV?
I'm sorry, what was the question? Is that on the chat?
Yes. Joe's, not the very last one, the second last one. Joe Androsani.
Oh, hey, Joe. Joe is a classmate of mine from University of Delaware. He always had these pointed questions that I could never answer, so it hasn't changed.
Sorry, Ramesh.
You know, I've read about this. I'm not very conversant with this, about China using high quality, poor quality coal to produce PV cells. I'm not familiar with this, Joe. If I'll get back to you on this, and you stumped me again, man, after 50 years.
Thank you.
One other question in here from Glenn. What is the source for the Duke Dominion Excel emission utilities commitments versus Ipcc data?
What is the source? I can, if you send me a note, I can send you the resource I used to get that graph. I don't have it all, sir.
Rudy, this is Dr. Coleman. Hey, how are you? Hi,
Hey.
everybody.
Yes,
So,
how are you?
I want to address this question regarding China using a lot of high quality, poor quality, high carbon. So coal is sourced in different deposits around the world. China's right now sourcing a lot of coal out of Australia. If you had noticed over the last 4 years, there was a really big uptick in the amount of coal being mined in the United States. Coal in the United States in some places is very dense, higher in bituminous ratings. It's more dense in carbon, less in sulfur in certain places in the Northeast. But in Australia, you have actually the formations of coal are a little, well, they have definitely higher sulfur ratings, and they're not as compact as some of the deposits that have been folded and thrusted in some of our belts in the United States. So they're a little younger in age, and they haven't spent as much time in the ground. And that is kind of, there's a whole, actually, many years ago, I'd say 50 years ago, there was a lot of universities that spent nothing more than times researching coal around the planet and the carbon intensity of coal. And places like University of Illinois and Champaign, very famous for their coal research center, and many mining departments across the United States. Colorado School of Mine, Lehigh used to be a school of mines. And so it really depends on whether it's subbituminous or bituminous. And it's probably because they're mining a lot of younger coal out of Australia right now, and it's being shipped up there. And that's probably the reason for differences in what they're burning. So I hope that helps. And there's tons and tons of literature on this.
Yeah. Thank you, Andy. A statement from on the chat, long-term role for natural gas is a big issue for net zero greenhouse gas goal. Fossil fuel, no doubt, John, you're right on the money. I think, overall 60% of our fuel for electricity in the supply side is fossil based. Natural gas is the dominant one, coal being second. It's not enough that we get away from coal. It's also important that we get away from greenhouse gas. Natural gas. So, we need carbon-free fuels then. And natural gas is not one of them. Unless, of course, carbon capture and storage is economically justifiable. Any questions from students?
Rudy,
Yes.
not a student, but just wonder if you would comment on the concern about hacking as digitization becomes more prevalent.
Wow, good question. Is that Joe?
Yes.
Yes, very good question. The short answer is very concerned. Even in things like virtual power plants, if that all depends upon the internet and digital information being transferred, shared. The real fear for utilities is what if somebody hacks into the price? So say it's $12 a kilowatt hour, I'm sorry, it was like 12 cents a kilowatt hour, and they make it artificially down, bring it down to like 0.12. They can buy it and it's been hacked, and the utility will be left holding the bag, as it were. So this has some very serious consequences as we go into a realm, where things like virtual power plants are being utilized, to take care of demand response and peak demand needs. Very real. There have been instances where people have been able to hack things so easily. So why should it be a surprise for them to get into grid? So yes, these are issues. Yes, they need to be studied. The answers may not be there today, but I think we need to come up with some answers. And if I may speak for some folks at Lehigh, they may not be in the audience, but there's research being done in that area, Joe. And so that could be very interesting. If there's a solution for that, it'll be really good. I'm sorry.
Alan,
Wala po, tuloy lang. Wala yun, tuloy lang.
So what's going on, guys?
I just muted Alan. If you have a question, can you please put it into chat, because there's a lot of background noise and we couldn't understand if you were asking a specific question. That was Alan Godwina. I think that's how you say his last name.
Sorry, Alan, if you can put it in the chat. There's a lot of interference. I couldn't hear anything.
Okay, Maria has a question. She says, you may not have the answer for this, but another source of carbon-based fuels is heating and cooking. Would you know if there is any plan to support the switch to clean electricity systems for these uses?
Hi, Maria. Maria is a former student, and nice. Thank you for asking this question. It's a very good question. Plans to support the switch to clean electricity system. I know I had experience with in Ecuador. They were going to support induction cooking, sorry. to replace this use of carbon-based fuels, I think it's a good idea. I don't know why it's not there are not more appliances that are being offered. I don't know what the landscape is here in the U.S. But in general, appliances have contributed a lot in reducing per capita consumption of electricity. I mean, they've done a terrific job. Why they can't do some more in this area is also kind of interesting. Maybe it's a price point. I don't know. But appliances in general have come a long, long way from what they were to what they are today. So indirect way of answering your question, Maria.
Okay, I missed one from Jim Daly. With respect to funding, compare the DOE budget to the entitlement budget in the federal government budget.
Okay. The question from John, what can Lehigh do with Mountaintop and Goodman campus to generate energy? Oh, very interesting. One of our capstone projects we are working on is looking at our campus as a source of, as a virtual power plant. We're still in the crawling stages, John, your question. Looking at an inventory of assets, seeing which ones are candidates and what would be the potential. So that's one of our capstone projects for this year, in fact. So, good question.
Rudy, I don't think you heard me when I said I missed one from Jim Daly. He said, with respect to funding, compared.
Yes, I heard that question. I don't have an answer.
Oh, okay. Well, I didn't.
I don't have an answer.
Okay. Okay.
Any other questions I'm waiting for some students to ask some questions.
Yeah, I just had one question. Just from the way that you presented this, I mean, we all know that nuclear energy is obviously something that could be a really viable source of electricity in the future that could, move above, natural gas and even coal generation. But like, what do you think is the biggest thing that's holding back from that? Is it politics? Is it public opinion of how they feel about nuclear energy? I feel like it's just like a bad taste in people's mouth when you say nuclear energy, but we know that it's actually relatively safe and we take care of it pretty well. So what is the thing that's holding us back, I guess, right now with that?
Very good question, Ryan. I'll tell you, it's sometimes the solutions aren't always technical, even though there's strong technical reasons. Sometimes perceptions. A long time ago, I remember hearing, there were some movies that painted nightmare scenarios. The China Syndrome was released in the 70s. There was a saying that the nuclear bomb was dropped before nuclear plants were operational. There was always this tie-in that had something to do with the bomb. Well, yeah, in some ways it does, but it's so well controlled, it's moderated. And it's, I think communication has a lot to do with it. How do you change opinions? I don't know. I mean, I think, I think Americans do really well when there's a crisis. When there's a crisis of climate change upon us, I think people do listen to reason, and hopefully something like that could have an impact. But again, nuclear is not complete answer. I mean, it's definitely a strong suit going forward, but perhaps that's it. I think the short answer is it's not always technical that's a problem. Unfortunately, it's a big bag, it's a mix of everything: politics, perceptions, behavior, economics, God knows everything else.
Thanks.
Joe's question about capital investment per kilowatt hour generated for nuclear power is very high due to permitting and regulations. Absolutely correct. I think in my class, I mentioned that the risk associated with nuclear plant construction is also always risky. You can never know which way the costs always head south, more and more costs because something was not anticipated. It's usually a regulation that crops up. I think one other thing is nuclear wants to be given credit for being a green energy, and some people don't want to treat it that way, for whatever reason. That could lower the cost, but anyway, Joe, you're absolutely right. Capital investment for construction for nuclear plants is very high because of permitting and regulations. And the permitting and regulations are absolutely on the money. I think you need that. And that's why they're high. John, financial risk of nuclear development is likely too much for the private sector to finance. And yes, in fact, that graph I shared, private funding is going to be, unless it's public-private partnerships, you're not going to get the carbon price to come for nuclear subsidies to match subsidies for fossil-based fuels, or at least the cheaper fossil-based fuels. All right, so any other questions? If not, we can. All right, so I'm going to put on my other hat, which is that of the MC. We will have a series of talks, 8 talks, as I mentioned, this semester. And at least on our website, or I don't know where we advertise this. Susan, can I shed some light? We have a lineup of speakers. How can we share this with the general public? Okay. Well, we'll put it on our website, the lineup of speakers for this semester. And as you can imagine, all these speakers have committed, but who knows, sometimes they're doing this on the goodness of their heart. And if we have to kind of postpone, cancel, or move the dates around, that we need to be ready for that. So we will have the list of speakers on the website for the semester. All right, if there are no more questions, thank you for your attention, and look forward to seeing you at future seminars. And the next one will be September 9th on water, from a person who's with the American Water Organization. And so water is another critical infrastructure. So, and utilities are big users of water, as you know. So there's a very interesting nexus right there. Thank you, guys. Thanks for your attention, and see you later.
Thank you. Thank you.
Thank you.
Thanks, Rudy.
Thank you.
So somebody, Susie, you still there?
Hey, Rudy.
Yeah. I don't know if you
Sorry,
heard my,
yeah, I step away for a minute. Sorry if I missed the end of that.
yeah. How can we publicize a list of speakers? You know, and we can say it's, you know, rev this and change it, the change in program. Can we put it on our website?
I believe so in the in that one section. Yeah, I just have to figure out how to do it in between everything else.
Yeah, you know, once we get this work study guy, you know, that'll help.
Yeah.
But what do you think?
Of about